This lecture introduces Chapter 5, the formation of stars and planets. Stars and planets form as part of the same process. Our learning goal is to understand this process. We compare our solar system to others to test our model of star and planet formation.
The evolution of the density, temperature, and pressure of gas clouds is central to understanding the formation of solar systems. First, these measured quantities will be reviewed.
What is temperature? Temperature is a measure of how hot or cold something is. From the physics point of view, temperature is related to how much thermal energy is in a system. In a very practical sense, temperature is what we measure with a thermometer. When two objects are placed in contact, heat will flow from the hotter object to the colder object until they reach thermal equilibrium. In a glass tube thermometer, such as the ones shown, a small volume of liquid expands or contracts when placed in contact with a hot or cold object. The object's temperature is determined by the length of the column of liquid. Temperature is a measure of the average thermal energy of the particles in a substance. Since it is an average measurement, it does not depend on the number of particles in an object. In that sense, it does not depend on the size of it. For example, the temperature of a small cup of boiling water is the same as the temperature of a large pot of boiling water. Even if the large pot is much bigger than the cup and has millions and millions more water molecules. We define temperature as a number that corresponds to the warmth or coldness of an object and measured by a thermometer. Temperature is a per-particle property with no upper limit. But there is a definite lower limit. Thermometers are instruments designed to measure temperature. In order to do this, they take advantage of some property of matter that changes with temperature. These are some of the earliest thermometers built by the Accademia del Cimento, 1657–1667, in Florence, Italy. These sensitive and exquisite instruments contained alcohol, sometimes colored, like many thermometers today. A reading of temperature occurs when the thermometer and the object reach thermal equilibrium, which means they have the same average kinetic energy per particle. As the liquid, mercury or colored alcohol, is heated, it expands and rises up the narrow tube. As the liquid in the thermometer cools, it contracts and the level drops. Infrared thermometers measures temperature by sensing IR radiation. Demo the FLIR. Demo the FLIR. There are 3 common temperature scales in use, many more exist. In the US we use the Fahrenheit scale, named after G.D. Fahrenheit, who worked in the early 1700s. In this scale, 32 degrees Fahrenheit is set as the freezing point of water and 212 for boiling point of water. 0 degrees Fahrenheit was established as the temperature of a solution of brine made from equal parts of ice and salt. The rest of the world uses the Celsius scale, named after Anders Celsius, 1701–1744. This scale uses 0 degrees Celsius for freezing point of water to 100 degrees Celsius for boiling point of water. In science, the Kelvin scale is used. The Kelvin scale, named after Lord Kelvin, 1824–1907. On the Kelvin scale, 273 Kelvin is the freezing point of water and 373 K is the boiling point of water. Absolute zero is at -273 degrees Celsius. The Kelvin scale is the same size degrees as Celsius scale. Note, in the Kelvin scale, the degree symbol is never written. Absolute zero is the lowest limit of temperature, is equivalent to -273 degrees Celsius. At absolute zero, atoms or molecules have lost all available kinetic energy. Substance at absolute zero cannot get any colder. The graph shows typical temperatures of various things in Kelvin and Celsius. There is no maximum temperature. As temperature of a gas changes, volume of a gas changes. At 0 degrees Celsius with pressure constant, volume changes by 1/273 for each degree Celsius. At absolute zero, the volume of a gas becomes zero. Since there is no motion of the gas, there can be no support forces. The hot the object, the brighter it glows. And it also changes colors. Heat an iron rod and its color shifts from deep red, to bright red, orange, yellow, and then white. The unique shape is known as a black-body curve. Recall that there is a relationship between temperature and how much light an object emits at specific wavelengths known as Wien's law. As the temperature increases, the peak wavelength gets shorter more towards the blue end of the spectrum. Wien's law yields the peak wavelength in nanometers when the temperature is specified in Kelvin.
Which color star would be the hottest? Blue, white, red, yellow. Pause the video and decide. The correct answer is blue. The blue star is the hottest.
Density is an important property of materials. It is a measure of compactness of how much space the mass of an object occupies. It can be thought of as the lightness or heaviness of materials of the same size. Density is the ratio of mass to volume. The density of various entities in the universe spans many orders of magnitude. The interstellar medium has a density on the order of 10 to the negative 19 kilograms per cubic meter, whereas a black hole of 4 solar masses is on the order of 10 to the 18 kilograms per cubic meter. Earth's surface atmosphere is about 1.2 kilograms per cubic meter. At standard pressure and temperatures, water is 1000 kilograms per cubic meter. The graduated cylinder shows various liquids that layer from most dense at the bottom to least dense at the top. Rocks are several thousand kilograms per cubic meter. In SI units, density is measured in kilograms per cubic meter. In CGS units, density is measured in grams per cubic centimeter. Pressure is the force per unit area that one object exerts on another. Pressure depends on the area over which the force is distributed. A force distributed over a very large area exerts a very small pressure. The same force distributed over a very small area exerts a very large pressure. The units of pressure are pounds per square inch, which we write as SI. In the SI system of units, pressure is measured in newtons per square meter, pascals, or millibars. 1 pascal is the same as 1 newton per meter squared, or 1/100th of a millibar or 0.000145 psi.
Which exerts a greater force, weight, on the ground? An elephant, a dog, a person, an ant. Pause the video and decide. The correct answer is the elephant. Which can exert the greatest pressure on the ground? An elephant, a dog, a person, an ant. Pause the video and decide. The correct answer is the person. But this is a trick question. It occurs under a special condition. The average weight of an elephant is around 5 tons, which is 44,482 newtons. Each foot of an elephant has an area of 450 square inches or 0.29 square meters. An elephant stand on all 4 feet distributes its weight over 1,800 square inches. Let's do the calculation. The pressure exerted by the elephant is over 38,000 newtons per square meter or again 5.6 psi. Consider a 100-pound woman wearing stiletto heels and all her weight is on one heel, as happens while walking. Her weight in newtons is 444 newtons and the heel is a square 1/4 inch on a side. Let's do the calculation. The total pressure is 1,600 psi.
A gas cloud is characterized by its chemical constituents as well as its thermal energy, measured by its temperature, its density, and its internal pressure. The ideal gas law relates the density to the pressure and temperature of a gas cloud. The gas density is equal to the ratio of the product of the molar mass of the gas constituents and its pressure to the product of the universal gas constant and the temperature. Stars are formed from the collapse of a molecular cloud. The duration of each stage of formation for a solar-like star is given in this table, along with the central and surface temperatures, the central density, and the cloud diameter. The protostar lives for several million years as it increases temperature and density and decreases its size during collapse of the cloud. When the central temperature reaches 10 million Kelvin, fusion of hydrogen to helium starts and the star is born. Stars form from clouds of gas. The density, temperature, and pressure characterize the stages of star formation. The next lectures will explain this process in greater detail.